All right, so we are covering 5 different methods of solving quadratic equations. So far, we have covered solving by graphing, where you look for the x-intercepts. We've covered solving by factoring. We've covered solving by square rooting, which you use when you don't have a bx term in your equation. And today we're going to look at solving by completing the square. So solving by completing the square is when you start with something in standard form. So ax squared plus bx plus c equals 0, right? Now, there are times when this method works better and times when it doesn't, and we will talk about when that is as we get kind of through some examples. But it is a handy little method to sort of have in your back pocket. Now, you should have done an activity in class that kind of walked you through where this came from, and hopefully you understand some of the concepts behind it. So today we're going to kind of talk about like actually doing it out algebraically. Okay, so step 1, if you need to divide by whatever a is. Okay, we always want to start with just a 1x squared. So like this one's all set. This guy, our first step would be to divide everything by 2. Okay, because we want to get rid of that and make it an x squared. Okay, once you do that, you're going to move your c term to the other side of the equation, basically just to get it out of the way. So whatever your constant is, like the 7 in this case, you're just going to move that over to the other side just to get it out of the way so we don't have to deal with it. Okay, once you do that, you're going to add, remember we said you're doing half of that middle term? Okay, well, my middle term right now would be b divided by a, right? Because we divided everything by a. So it was b, but we divided it by a, and we're taking half of that. So it's going to be b over 2a. Okay, and then you square that, and that's what you're adding to both sides, right? So you've already divided by a to get b over a here. You're taking half of that and squaring it and adding it to both sides. Okay, so what that means is that now on the left side of your equation, what you're going to have is you're going to have the x squared, you're going to have the b over ax, and then you're going to have this b over 2a squared that we just added on. Okay, and we're going to factor that. So we need two things that add to b over 2a squared, or I'm sorry, multiply to b over 2a squared and add to b over a, right? Well, that's just going to be b over 2a. Okay, so we're going to factor that, and then we'll solve from there using the square root method. Okay, so it sounds really complicated when you write it as steps, but it's actually not too bad. So let's run through this first example. So if needed, divide by a. I don't need to do that because I already have a 1 in front of the x squared, so we're set. Okay, so step 2, I'm going to move this c over to the other side. So I'm going to bring that 7 over to the other side. And when I do this, I'm going to leave a little bit of a gap here. Okay, so I leave a little bit of a gap. All right, and that is where I'm going to add to both sides of my equation. Okay, so I move c to the other side, and now I'm going to add b over 2a squared. So that sounds complicated. We already got, this is b over a. So we're going to take half of this number and square it and add it to both sides. So half of negative 10 is negative 5. Negative 5 squared is 25. So I'm adding 25 on both sides of my equation. This right here is the number 1 step that people don't do. Okay, so make sure you add that on both sides of the equation. All right, once I've done that, now I can factor this half of the equation. Two things that multiply to 25 and add to negative 10, negative 5 and negative 5. So this is x minus 5 squared. And then on this side, 25 plus negative 7 is 18. Okay, and then from there, now I can just solve this using my square roots, right? So I'm going to square root both sides of the equation. Okay, and that's going to give me x minus 5 equals positive or negative square root of 18. Okay, I'm going to bring that 5 over to the other side, so it'll be 5 plus or minus the square root of 18. And then I'm going to simplify my square root. So the square root of 18, that's 9 times 2, and the square root of 9 is 3. So it's 3 times the square root of 2. And that right there is my answer. Okay, if you need to do that simplifying of your square out, right, if you need to simplify this out on the side, do some side work, that's totally fine. Okay, and that's it. That's how you complete the square. Okay, so it's a nice little method that can be really handy when you have something that won't factor. Like this guy, he won't factor at all. So we could use completing the square, and it's a little bit of a weird process because you probably haven't done it before, but once you kind of get used to it, it's actually pretty convenient. Okay. All right, now this guy over here, this one's kind of a mess just because we have stuff everywhere. We're not yet in this ax squared plus bx plus c equals 0 form. So that's going to be the first thing I'm going to do is I'm just going to rearrange this a little bit so that it's in the correct form. Okay, so let's see, it's going to give me 2x squared, and then I'm going to bring this over here. That'll be negative 14x. The 4, though, I might as well leave over there because I know that's going to be my next step, right? So I might as well leave that over there. And notice again, I kind of left that little gap there where I'm going to add on both sides. Okay, so from here, half of negative 14 is 7, negative 7, and negative 7 squared is 49. So I'm adding 49 on both sides of my equation. And again, that right there is the step that people forget the most often. What I tend to see a lot is people jump right from having this to here, and they forget that they have to add the 25 on both sides, or in this case, the 49 on both sides. So they'll like take this part and drop it down into parentheses and just leave it as a 4. That's my most common mistake that I see. Oh no, speaking of mistakes, I just made one. I skipped a step. Hang on. That's not what I want to do. Right? I can't do this if it's got a 2x squared. I need to change this into a 1x squared. So my bad. What I'm actually going to do next is I'm going to divide the whole thing by 2. So I'm going to make this x squared minus 7x equals 2. I forgot that step. Move c to the other side, right? But divide by that a if you need to get it to be a 1x squared. I apologize. All right, so now that we have that, now we can do this half of b squared thing. So negative 7, half of negative 7, well, I'm just going to think of that as 7 over 2, right? So half of negative 7, that's the same thing as 7 over 2, right? Okay, and then when I square that, well, 7 squared is 49 and 2 squared is 4. So that's going to end up being 49 over 4. Okay, so I'm adding 49 over 4 to both sides. Okay, and I can tell already some of you are going, I don't want to do this. It's all right, it's not that bad. All right, so then on this side we can factor this, right? And remember, this is always going to factor 2 things that multiply to this and add to that. It's always just going to be half of whatever this number is. So minus 7 halves, right? Half of this number, when you square it, gets you here. And I know that that's the case because that's how I literally found that number, right? How do we know what number to add here? Well, I took half of this and then I squared it, right? So that's the number that I'm looking for here. Okay, and then on this side, so 2 plus 49 over 4. So I know that 2 is the same thing as 8 over 4, right? So then I'm adding 49 over 4. So that's going to be 57 over 4, right? Okay, just doing a little bit of work in my head. Cool. Okay, so now I'm going to square root both sides. So that'll leave me with x minus 7 halves equals positive or negative. Top will have the square root of 57, but on the bottom, the square root of 4 is just regular 2, right? So that's convenient because I'm not going to have to rationalize anything. And the square root of 57 doesn't actually simplify. Okay, and then last step is I'm going to add this to both sides. So it's going to be over here. And you can kind of write it 2 different ways. So you can write it as 7 halves plus or minus root 57 over 2. Or because these have common denominators, you could also write it as 7 plus or minus root 57 over 2. Same thing. Okay, and there's our solution. Okay, so this is how your completing the square method works, right? So really quick, let's talk about when is the ideal situation to use this, right? Solving by factoring is ideal to use when you can factor it. Solving by graphing is convenient to use when you're going to have whole number answers. Solving by graphing, you're not going to be able to really get answers like these. So that's one's not really a good one. Whole numbers are best for graphing. Solving with square roots is convenient when you don't have a b term, right? So what about solving by completing the square? When is this easiest? Well, it's easiest when, after you get it into this x squared form, your b value is even. Because then when you take half of it, you're still going to have a whole number, right? That's what made this one a little less convenient, was that this was an odd number. And that's what kicked us into fraction territory, right? So it's not necessarily when this guy's even, but it's after you get rid of that a value, when what you have left is even. That's what makes completing the square an ideal method to use. All right, so then last but not least, vertex form, right? So we had talked about how to take something that's in standard form and put it in vertex form by calculating the vertex and then going from there. So this way, we're going to do the same thing, but we're going to do it using completing the square instead. Okay, so what I'm going to do first is we're going to follow kind of the same process. The first thing that I'm going to do here is I'm going to divide everything by 3 so that I have just that x squared. Okay, so when I divide by 3, that's going to leave me with y over 3 on this side, right? Equals x squared. 42 divided by 3 is 14, right? And then 15 divided by 3 is 5. Okay. Now you've got two options with this 5. You can either subtract it from both sides so it shows up over here, or what I usually end up doing is I just kind of shove it out of the way. Okay. So what I'm going to kind of do is I'm just going to sort of move it so it's over here and it's just sort of out of the way, and I'm going to ignore it for now. Okay. So then I got to figure out what am I adding to both sides. So half of 14 is 7. 7 squared is 49. So I'm going to add 49 over here, and I'm going to add 49 over here. All right, so now that we've got this set up, now we can actually do our completing the square. So this bit right here, right, this part right here, I know that's a perfect square. That's x plus 7 squared, right? I've still got this plus 5 chilling out over here. On this side, I've got that y over 3 plus 49. So then I'm going to have to bring the 49 over here. So I'll subtract that from both sides, and I'll have y over 3 equals x plus 7 squared, and then it'll be minus 54, I believe. Okay. All right, and then from there, all I have to do is multiply everything by 3 to get the y by itself, right? So my last step is going to be to take this entire equation, multiply the whole thing by 3. So this will cancel out to just be a regular y. When I get this set here, though, you can't distribute this 3 over the x and the 7 because the squaring goes first before multiplying in order of operations. So I'm just going to write it as 3 times x plus 7 squared. And then 3 times negative 54 is something 162. So there's my equation in vertex form. All right, so that's where you're going to get this vertex from, or vertex form from. Oh, here it is. Oops. My plus 5. I magically made it into a minus 5. That was supposed to be a plus 5, right? So that changes things a little bit. So when I subtract here, then this would be a 44, right? And then 44 times 3 is only 132. Yeah, sorry, my bad. Sorry, this day is just kind of plagued. Okay, so anyway, there's my equation in vertex form. Now, I do want to kind of show you just one other way, because when I made out your answer keys, I think I kind of did it 2 different ways organizationally. Okay, so there's also an alternate way that we could have done the exact same thing. It's just going to show up a little bit different. Okay, so instead of dividing everything by 3 and writing it as y over 3 over here, another method you could have done is you could have left it as y equals and treated it more like you were factoring the 3 out of the 3x squared plus 42. So left it then as x squared plus 14x. Leave my gap there. And the plus 5, I'm not going to factor the 3 out of. So I'm just kind of leaving that at the end, or the 15, excuse me. It's a 15. Right? So see how I took this? I kind of kicked the 15 out to the end, and I just factored this first bit here and left it like that. Okay, so then from there, when I go to solve this, I'm going to do the same thing. Half of 14 squared is 49. So I know I'm adding 49 here. Okay, but then here's where the difference comes in. I added 49 inside of this set of parentheses, but inside of this set of parentheses is already claimed to be multiplied by 3. So when I add on this side, I'm not going to add 49 again because I didn't actually add 49 over here. Even though I wrote plus 49, I actually added 3 times 49, right? So when I add on the other side, I'm going to add 3 times 49, which is 147. Okay, so then I have on the left side y plus 147. And on the right side, I've got 3 times, factor that into x plus 7 squared still. And then the plus 15 is just chilling out. And then when I subtract that 147 from both sides to get the y by itself, right, and to make sure I combine that with its like term, that's where you're going to get that negative 132. So it gets you to the exact same place. So you can do it either way. It's really just a matter of preference. I think this way's a little bit easier. Like this one wasn't bad because of the 15 divided by 3, right? When we did this divide everything by 3, everything divided by 3. So that was pretty convenient. But in this method, if this didn't divide, you'd still be okay. Like if this had been like a 14 or something, over here you'd end up with fractions. Over here you wouldn't. So it's really just a personal preference, and I'm trying to think of what I did on your answer keys when I worked out your worksheets, and I think I did kind of a mix of both ways because they're both kind of handy to have in your back pocket for when you need them. So either way works. You're going to get to the same answer, and it's just kind of a preference thing. Okay, so that is how you solve by completing the square. All right, you should be kind of, maybe there should be a couple of things in here that are sort of twinging your attention, and you're saying, this feels, something about this feels sort of familiar with these B's and 2A's and stuff. So kind of see if you can dwell on that a little bit, and we'll see if we can figure that out at a later time.